So the final operation we have for scientific notation is when we end up dividing our scientific notation numbers. It's very, very similar to multiplying. So the first thing about dividing our scientific notation is it follows the same basic rule of the quotient rule of exponents. So when you have two identical bases, so when you're talking about exponents and powers, you have the same base, you have 10 and it's being divided by 10, they're identical. And indeed dividing, that's how we get the quotient rule. Quotient does mean division. So there they are, they're dividing. Those powers subtract. So right now the 10s I have are 1 and 1. But let's make them a little bit larger. Let's say we have 10 to the 4th over 10 to the 2nd. The quotient rule says that the two identical bases, the 10s, they're dividing. I get to take the top power, I'm going to subtract the bottom power, and I end up getting 10 squared. Few different ways we can kind of visualize this to see that the answer is 10 squared. Let's take these two numbers and let's expand them out. 10 to the 4th is 10,000. 10 to the 2nd is 100. And 10,000 divided by 100 is 100, which is 10 to the 2nd. Another way you can kind of visualize it is you've got 4 10s on the top. We've got 2 10s on the bottom. 10 divided by 10 goes away. 10 divided by 10 goes away. You're left with 10 times 10 on the top, which is once again 10 squared. So that is the same basic principle that happens within the quotient, within dividing scientific notation numbers. So a couple things. The powers do not have to be equal when you divide scientific notation. We're going to divide the numbers of our scientific notation while we subtract the powers. So remember, every scientific notation is comprised of two parts. That first part being the number and the power. And then at the end, we're just going to check to make sure that we're still in scientific notation. So for instance, I've got this problem right here. 9 times 10 to the 4th divided by 3 times 10 to the 2nd. We've got two different problems that are happening at the same time. This is the first one. I'm going to take 9 and I'm going to divide 3. I end up getting 3, keeping it simple for our first example here. 9 divided by that 3 gets us 3. Turn our attention to the second half of the problem, 10 to the 4th divided by 10 to the 2nd. Just did this on the last slide. 4 10s on the top, 2 10s on the bottom. We take that 4, we subtract that 2, we get 10 squared. We put the two pieces together, and now we check to make sure we're in scientific notation. So there's the decimal point. You're only allowed to have one digit, I should say to the left, not just left, to the left of the decimal, which we do. We are correct. Maybe the number is a little bit more intense. 7.27 divided by 5.98, and then 10 to the 5th all over 10 to the 4th. We approach it the same way. We're going to just worry about this number right now. I'm going to grab my calculator, because we don't have to divide it by hand. 7.27 gets divided by 5.98. So here's this really long decimal. I'm only going to write the first 4 digits of it. 1.215. Let me just double check I copied that. Yep. So there's our number. I'm going to slide it over and put it right there. Now I'm going to turn my attention to the power of 10. I got 5 on the top, 4 on the bottom. So 5 minus 4 is 10 to the 1st. put my two pieces together right here. We're going to check for scientific notation. We do indeed have one digit to the left, but then we're going to round to 2 places. So I just want to keep these two numbers. The 5 causes the 1 to round up to 1.22 times 10 to the first. If you have negative powers within the quotient rule, it doesn't change the process. We just have to be a little bit more careful because negatives don't work the same as positives. They work a little bit different, a little bit more complicated. So I'm actually going to start with the power of 10 since that's the major piece of what this problem is. We're still going to take that top power and we're going to subtract the bottom power. So my top power is -3, and I'm going to subtract my bottom power, -4. Well, -3 minus a -4, these two minus signs actually combine and give us plus. So we're really taking -3 plus 4. Well, -3 plus 4 is 10 to the first. And that's our power of 10. Now we're just going to divide our numbers. So if we're going to bring my calculator back up, I've got 3.27 divided by 2.11. We get this long string of decimals. So I'm going to keep these 3 right here, 1, 5, 4, 9. 1.549. We check for scientific notation. We have that one digit to the left, so we're good there. Now we're just going to round to 2 decimal places. The 9 rounds the 4 up to a 5. And there's our final answer. Last problem with top number is positive, bottom number is negative. Again, the power is all the same. We're going to take that top power, 10. We're going to subtract the bottom power, -2. Just like the last problem, negative and a negative creates this big plus sign, so we really have 10 plus 2. The power of 10 is 12. Then we're going to let the calculator do the work. 3.2 divided by 2.8. And we get 1.142. 1.142. Keep 2 decimal places. In this problem, the 2 does not round it up, and we're just left with 1.4 or 1.14. Apologize. Times 10 to the 12. There it is. If you go through when you're dividing, and you end up getting a problem that ends like this. So you have your division problem, and the answer lands you here. This is not scientific notation. We need to have that one digit in front of the decimal, and it can't be 0. So we're going to grab this decimal point. We're going to move it 1 spot to the right, and we now have 8.32. But since this number got larger, our power of 10 has to get smaller to make sure everything stays balanced. And that's 10 to the 6th. This would be your final answer if you were not in scientific notation to start with. And that's dividing scientific notation.